Okay, just saying this again. Here's a table for 2 to the x. And that we all understand this. Okay. We want to do a table for f of x minus 1. If f of x is 2 to the x, f of x minus 1 is 2 to the x minus 1. Now, our x values aren't changing. X is still -2, -1, 0, 1, 2. We're going to have to plug these x values into this formula. Okay. And we can do that directly, but to help us see what's going on, I'm going to do a column for x minus 1. So I don't have to keep looking back here and calculating x minus 1. I'm just going to calculate x minus 1 values. And then to do this, I just have to plug these values into 2 to the x function. Okay, so x minus 1 would be -3, -2, -1, 0, 1. Make sense? Okay. So 2 to the x minus 1, if x is -2, would be 2 to the -3. 1/8. For x equal to -1, x minus 1 is -2. So 2 to the x minus 1 is 2 to the -2, which is 1/4. When x is 0, x minus 1 is -1. We get 2 to the -1 is 1/2. When x is 1, x minus 1 is 0. We get 2 to the 0 equals 1. And here we get 2 to the 1 equals 2. Now, look at these numbers and these numbers. Show me with your fingers how many of these numbers appear here. Okay. You see 1/4? Do you see 1/8 over here? No. You see 1/4? Well, if you know the table, if you've done what you need to do to understand the 2 to the x function, you know 1/4 is one of the values of the basic function. And so is 1/2, so is 1, and so is 2. Of course, you can find 1/4, 1/2, 1, and 2 over here, right? Okay. So, I can kind of circle these numbers and see how they occur over here. Okay. But these numbers occur over here for one number less. Okay. In other words, 1/4 occurs here for what value of x? X equals -1, right? 1/2 occurs on this function when x equals 0. Whereas 1/4 and 1/2 occur for x values -2 and -1 here. Okay. So I'm not going to write out the complete statement, but we see that these values occur here for 2 to the x when x is one value less. Okay, which means that the graph of this function is going to be 1 unit to the left of the graph of this function. Okay, so the graph of 2 to the x is 1 unit to the left of the graph of 2 to the x minus 1. So if we do the two graphs, Yeah. And of course, I'm assuming you're very familiar with this graphing that you've done it a number of times. So the extended function would look like this. The basic function looks like this. This is your 2 to the x function. Y equals 2 to the x minus 1 is going to have values 1/8 here. So you got to subdivide this 1/4 into 2. So it's going to be somewhat lower. And then here's going to be half as great. Here's going to be half as great. Here's going to be 1 instead of 2. Here's going to be 2 instead of 4. So this is y equals 2 to the x minus 1. Now look, we're going to relate this to the written assignment from last week. Okay, now these arrows are a little easier to see than these, but it looks like each of these arrows has what length? What's the length of this arrow? Yeah, please don't use speak because we're recording, but yeah. Okay. Right. Everybody see that? What's the length of this arrow? 1, right? And the length of this arrow, and the length of this arrow, 1. So since the graph of 2 to the x is 1 unit to the left of the graph of 2 to the x minus 1, because these values occur 1 unit earlier for the 2 to the x function, well, we can also say that these values occur 1 value of x later. So the values of 2 raised to the x minus 1 are shifted 1 unit horizontally from the values of 2 to the x. Okay. For the same reason that you might want to think about, graph of f of x minus 1 is always 1 unit horizontally from the graph of f of x. Okay. And we can even extend this and say that the graph of f of x minus h is always h unit, let's say units, horizontally from the graph of f of x. In other words, if this was 2 to the x minus 2, then these values would occur 1 unit further along. These values would lag these values by 1. So these values would be, or by 2, I'm sorry. So these values would be 2 units ahead of these values. So That's how you horizontally shift a function. F of x minus h is always horizontally shifted h units in the horizontal direction. Okay? Always. Now that's a little counterintuitive because you see that minus and think, well, it ought to be shifted that way because of the minus sign, right? It's real easy to get confused, which is why I start with this and show you why it isn't minus. This is minus from this. So this is plus from this. If you understand the table and you want to try to understand this as clearly as you can so you don't do it backwards. Okay, shift in the wrong direction, and I'm not sympathetic when I'm grading. Okay. Got to get it right. Okay, well, that's maybe the hardest thing to understand, but there are a couple of other things that happen with transformations. Now I'm going to illustrate as many of these as I can, but I'm just going to give you the other two main rules. If you do f of x plus k, then if you got the graph of f of x, you just raise every point by k units. Now, if k happens to be negative, of course, you're going to go negative shift in the vertical direction. So these are both shifts. The first couple of shifts I had you do, I had you shift whatever that function was that you graphed to the right. So if that graph that you had was f of x, when you shifted it to the right, it was f of x minus 4, 5, 6, whatever number of letters in your name, right? Okay. And then when I said shift it vertically, if you shifted it vertically 5 units, then that was, if the original graph was f of x, the graph that you got was f of x plus 5. The plus 5 is not in the parentheses. If it was, then you'd be shifting 5 units to the left. So this is not too hard to understand, is it? In terms of what you did, that's why I gave you the assignment. Okay. And another thing is, I have some outstanding students taking third semester calculus. You need 4 semesters of calculus, you want to be an engineer. Okay. These guys have pre-calculus. Now they had it maybe during the COVID year, maybe, but probably not, because last year they were taking first year calculus. They needed to know this today. And they didn't have a clue. Okay. It's because, and they're very bright. Now, they understood it instantly when I explained it, but they didn't remember having done it. Okay. And that's really common. People that have had a calculus course come into my physics course or into a third semester, fourth semester calculus course. They don't remember the essence of what they had in calculus. First thing we did in physics was the rate of change. I said, just remind you anything in calculus? No. We went into more detail. Never did remind them what they did in calculus. Okay. One thing I try to do in my courses is make sure that you know deeply what things mean, because it makes it much easier at the next step. Okay. Now, I had physics at the same time I had calculus. So I had to learn two of them together. And, you know, I'm reasonably smart. Took me a good year after having those courses to sort it all out. Okay? Because you lose, you don't see the forest for the trees. You're so busy learning the rules of the chain rule and all this stuff and doing proofs. Because we used to do proofs in mathematics. That you never get it. But I want you to kind of focus on what things mean and how meaning is related to what you do with the sentence. It will benefit you in your further mathematics. You won't have to keep relearning the same stuff. So what I'm saying about, you know, these guys, they're bright. Okay. They knew about what I would have known if I'd have had the same courses. Okay. So no insult to them. But we interviewed some candidates for the president. There were two outstanding candidates. We hired one of them. The other outstanding candidate was a guy with an advanced PhD in mathematics. Okay. He's a good guy. So I'd have been happy with either of them. Real happy with the guy we got. But he even commented so that, you know, about how people get out of math courses and don't understand anything they did. So try to understand. Okay.